All right, y'all, let's integrate the integral from 0 to 4 of 5 over 3x plus 1. Remember that when you integrate anything of the format of 1 over x dx, we know that this is going to equal to the natural log of the absolute value of x plus c. So we're going to eventually want to convert this format on this particular problem. So what's the easiest way to approach this? Well, first thing is let's just yank this 5 out so I'm not looking at more than what I need to. So we can see when we do this that this 1 over 3x plus 1 is eerily similar to this 1 over x. So now it's time to bring about our old friend u sub, and so we're going to say let u equal 3x plus 1, take the derivative, and we'll get du equals 3 dx, or du over 3 equals dx. So I can replace the dx with du over 3. I also can replace 3x plus 1 with u. And so this gives me 5, integral from 0 to 4, 1 over u, du over 3. And then from here, what I want to do is this 3, let's put this on the outside. So when I put that on the outside, I got 5 times 3, which is 15. Integral from 1 to 4, 1 over u du. So now we know we have, I wrote 15. I'm so sorry, I made a mistake here. It was not 15, it was 5 over 3 because this 3 is in the denominator. So it's 5 over 3, integral from u to 4, 1 over u du. The one good thing about when I make a silly mistake is if you were like, what is this guy doing? Then that means that it's making sense to you. If you didn't catch that, then that means that you need to be a little bit more careful. Maybe you rewatch some of these videos. Okay, so in any case, we get 5/3. Now we're just using what we know, which is that the integral of 1 over x is the natural log x plus c. So this one's going to be 5/3 because we have the 5/3 on the outside. The natural log of u, and normally we'd say plus c, but we have to do the bounds. Now the bounds is an interesting thing because different people do different things at this point. If I go 0 and 4, these are in regards to x. What some teachers will do is tell you to take the 4 and the 3 and plug it in here. I'm sorry, 4 and 0 and plug it in here to find what it is in terms of u. So let's go ahead and do that. So for the first one, it'll be 3 times 4 plus 1. I'm just plugging in here. This will give me 13. If I use 0 on the bottom, I'm going to have 3 times 0 plus 1, which is 1. So what my new bounds are 13 and 1. So you can use those. You also could replace u with 3x plus 1 and then plug in the original values. It's just whatever makes you happy. So this ends up giving me 5/3 natural log. So what's going to happen here? Well, we're going to say 13 minus the natural log of 1. Now, this is kind of a cool thing here because you can go back to college algebra or algebra 2 and use the properties of logs, and you could rewrite this just as natural log 13 over 1. I can drop the absolute value bars at this point because 13 and 1 are both positive, and that would be the answer. Or you could recall that the natural log of 1 is 0, and so you're just left with the natural log of 13. But in any case, the answer is going to become 5/3 natural log 13. Hope that makes sense, and I'll see you in the next math video. Please, if there was any comments, if someone sees something like this and there's something that you're looking at that doesn't seem right, I wasn't clear, I misspoke, please let me know in the comments and I will edit accordingly. All right, hope this helps you guys out. Bye-bye.